Hello everyone, welcome back to this online class. Today we are going to look at numerical solution of ODEs, and we are going to look at the boundary value problems, and our method is Numerov's method. Now we have this question. We are asked to use Numerov method to solve the boundary value problem given by d squared y over dx squared is equals to x plus y. Our boundary conditions are at x is equals to 0, y is equals to 0, and at x is equals to 1, y is equals to 0. We need to use the step size h is equals to 0.25 and compute the values of y of 0.25, y of 0.5, and y of 0.75 correct to 5 decimal places. Now, what is important about Numerov's method is that it is applicable when you are solving an ODE of the form d squared y over dx squared is equals to a function of x, y. When you have such kind of an equation, you can use Numerov method. You see, it is only the second derivative. We don't have the first derivative in the equation. If we have the first derivative in that equation, then you cannot use Numerov's method. And the boundary conditions are that y at x naught is equals to y naught, and y at xn is equals to yn. These are called Dirichlet boundary conditions. Now let's see how to go about this kind of a problem. Now, first of all, let me explain what we mean by these conditions. We have the condition at x naught, which is 0, and the other condition at x1. So I'll draw a line just to illustrate what we mean by those conditions. At 0, let me use here 0, x naught, our step size is 0.25. So from 0, I'll move in steps of 0.25 all the way up to 1. So the next will be 0.25. Continue moving in the same step size of 0.25. You get to 0.5. The next is 0.75. And finally, the last one is 1 because we want to go all the way up to 1. So this is x naught, x1, x2, x3, x4. What is the corresponding values of y? At x is equals to 0, y is equals to 0. So I'm going to write 0 here. It is here. At x is equals to 1, y is equals to 0. So another value of y is 0 at the other end. So what does it mean? That this is y naught, and this other value is y4, corresponding to x4. So I don't know the value here, this one, and also this. So this value will be y1, this is y2, this is y3. So the task is to find y1, y2, y3. When we write y1, it is the same as y at x1, which is simply equal to y at 0.25. This is what we need to find. Let me put a question mark. You also need to find y2, which is the same as writing y at x2. And when I replace x2, I'm going to get y at 0.5. I also don't know this. And lastly, we need to find y3, which is the same as y at x3. And that is y at 0.75. We also don't know this one. Now, having understood what we mean by those boundary conditions, now let's go back to our ODE. D squared y over dx squared is equals to x plus y. This is our f of x, y. F of x, y. So we are given that f of x, y is equals to x plus y. Now, This is the formula, the iterative formula for the Numerov's method. So our iterative formula is iterative formula for the Numerov method is, that is yn minus 1. Let me use I instead of n. yi minus 1 minus 2 y subscript I plus yi plus 1 is equals to h squared over 12 times f I minus 1 plus 10 fi plus fi plus 1. Remember that, let me first of all bracket this. Let's bracket it. So remember, I ranges from 0 all the way up to n. But for this case, our unknowns are when I is 1 and I is 2 and I is 3 for this case. So in this case, I ranges from 1, 2, and 3. Those are the unknowns when y1, y2, and y3. Already we know y0 and y4. So that's why I've neglected 0 and 4. So when I write f of xy, or simply fi minus 1 here is the same as writing f of xi minus 1, comma, yi minus 1. And so look at our f of xy, it is x plus y. So when I want f of xi minus 1, yi minus 1, where there is x, I'm going to put xi minus 1. And where there is y, I'm going to put yi minus 1. So it will be xi minus 1 plus yi minus 1. Similarly, fi is equals to f of xi, comma, yi. And so this is the same as xi plus yi. And another one is fi plus 1. This is the same as f of xi plus 1, comma, yi plus 1. And this is the same as xi plus 1 plus yi plus 1. Those are very important. Now, having known the iterative formula for the Numerov method and also having understood our boundary conditions and the step size h, which is 0.25, let's now see how to iterate. We are going to iterate from I0, I1 up to 3. So this is the value of I. So we have just 3 iterations. So you can start, put I is equals to 0. I is not 0 but 1. We are starting with 1, remember. When I is equals to 1, what are we going to get? It will be y0 minus 2y1 plus y2 is equals to h squared over 12 into f0 plus 10 f1 plus f2. First of all, let me compute the f0, f1, and f2. So from here we have our f0 is the same as f of x0, comma, y0, and that is the same as x0 plus y0. Our x0, you can read it from the diagram that you drew. Our x0 is 0 and our y0 is 0, so the answer here is 0. f1 is equals to f of x1, y1. That is the same as x1 plus y1. From this diagram, our x1, let me take you back to the diagram. It is here. So our x1 is this value, which is 0.25. y1 we don't know. So I'm going to write 0.25, 0.25 plus y1, which we don't know. Our f2 is the same as f of x2, comma y2. And this is x2 plus y2. We only know x2 to be 0.5, but I don't know y2. So leave it in terms of y2. So I have found f0, I've found f1 and f2. I also know h, so I can replace what we know. So you can say that therefore, we also know y0. Remember, y0 is 0. So therefore, we will have our y0, which is 0 minus 2y1, we don't know y1, plus y2 is equals to h is 0.25. You square this, divide by 12, then times our f0 was 0, 10 f1, f1 is 0.25 plus y1, our f2 is 0.5 plus y2. So you are going to collect lectures because I can see there's y1 on the left-hand side, another one on the right-hand side. Similarly, there's y2 on the left and the right-hand side. When you reorganize this equation and or collect the like terms, take everything to the left-hand side, this is what you're going to get, that negative 394y1, you can write, or negative 394y1 plus 191y2, 191y2. On the right-hand side, you need to get 3. So this is the first equation. Call it Roman 1. I'll bracket it. Our first equation. Let's go to the next iteration. Put I is equals to 2. So you write put I is equals to 2 in the same iterative formula. When I is equals to 2, we are going to get y1 minus 2y2 plus y3 is equals to h squared over 12 into f1 plus 10 f2 plus f3. That's the new formula when I is equals to 2. What do we know? We know f1, we also know f2, but I don't know f3. So let me find it. Now this is how we are going to find f3. So write down here that, let me use blue, that f3 is the same as f of x3, y3. And based on our definition of f of xy, which is x plus y, so this is the same as x3 plus y3. Do we know x3? Yes, that was 0.75. Do we know y3? No. So let's leave it as that one. So again, we know h. Let us now replace all those values that we know. So therefore, I don't know y1, then minus 2y2 plus y3 is equals to 0.25, this is squared, over 12 times our F1, we got 0.25 plus Y1 plus 10 times our F2 is 0.5 plus Y2 plus our F3, which we have just found as 0.75 plus Y3. You see, we have Y1 on the left, another one on the right, Y2 on the left, another one on the right, Y3 on the left, another one on the right. You need to open the bracket on the right-hand side and then take everything to the left-hand side and collect like terms. When you do all those, you need to get this equation that 192y1 can write or 192y1 minus 384y2 minus 384y2, of course it's 394. Let me rewrite it. We are simplifying, which I know you know how to do. When you simplify it further, you need to get 191y2, y1 minus 394 y2 plus 191 y3, 191 y3. That should be able to give us 6. This is equation number 2. So again, I'll bracket it. And lastly, the third iteration is when I is equals to 3. So you can write put I is equals to 3. In the Numerov formula, we are going to get y2 minus 2y3 plus y4. That should give us h squared over 12 into f2 plus 10 f3 plus f4. I know f2, I also know f3. Let's find f4. So you can write f4 is the same as f of x4 y4. And this is the same as x4 plus y4. Do we know x4? That is 1. Do we know y4? That was 0. So when you work it out, you need to get 1. Remember, I'm reading the values of x and y from this diagram that you drew here. This way you get the values of x naught all the way up to x4, y naught all the way up to y4. So like x4 is 1 and y4 is 0. So let's go back and replace it. So therefore, we are going to say that therefore, do we know y2? Let's replace what we know. Now we know f4. We also know y4 and we know h. So let's replace all those. So we'll have y2 minus 2y3, those are unknowns, plus y4, which is 0, is equals to 0.25, that is h, you square it, divide by 12, f2, you can go back and check, that was 0.5, it was here, this one, 0.5 plus y2, that's our f2. So we write 0.5 plus y2 plus y2. Then f3 is this one. So we'll have 10 times f3, which is 0.75 plus y3. And finally, our f4 is 1, so plus 1. Simplify, you can see there's y2 on the left, another one on the right, y3 on the left, another one on the right. So you can open the bracket on the right-hand side, take everything to the left-hand side, and then collect like terms. Once you do all those, you need to get your equation as 191y2, 191y2, minus 394y3, 394y3, and the right hand side you need to get 9. Remember, when you get fractions, you need to multiply, get rid of the fractions. That's why you see my coefficients are just integers. You multiply through by the LCM so that you can get the equation that I've found. So this is your equation number 3. Equation 3. And so I'll also bracket it. So our task is to find y1, y2, and y3. Those are 3 unknowns. And we have 3 equations. So we are solving 3 equations in 3 unknowns. So we are going to solve equations 1, 2, 3 simultaneously. So you can write here solve equations 1, 2, and 3 simultaneously. To get, because you know how to solve simultaneous equations, these are the values that you need to get for y0, y1, y2, and y3. The first one is y1. Remember, when I talk of simultaneous equations, there are so many methods of solving simultaneous equations. You can use substitution method, you can use elimination method, you can use matrix inversion method, or you can use Cramer's rule, or any other method that is easier for you. So use any method, you are going to get the same values. So our y1 is equals to negative 0.03505. Negative 0.03505. Y2 is equals to negative 0.05659. 0.05659. And lastly, y3 is equals to negative 0.05028. 0.05028. Remember, we are rounding off correct to 3 decimal, not 3 but 5 decimal places. So what we are calling y1, we said this is the value of y at x is equals to 0.25. We have found it. This other one is the value of y at x is equals to 0.5. We have also found this. And finally, this one is the value of y at x is equals to 0.75. So this is how to apply Numerov's method to solve a boundary value problem. So thank you all for watching this video. Please subscribe to my YouTube channel. That is Professor Francis Okage. When you go to the YouTube search, type Francis Okage or Prof. Francis Okage, and you will find me right there. Also, don't forget to comment, like, and share this video. When we meet next time, we look at more problems involving numerical solution of boundary value problems. Bye-bye.